Hello everybody. We are going to cover master cylinders. So we're going to take a look at the master cylinder and its components, its operation, some of the diagnosis, brake tubing, and brake bleeding. Alright, so the master cylinder is going to convert the motion of the brake pedal into hydraulic pressure. We use a tandem master cylinder now, and it has it consists of a reservoir tank, and it has a secondary and a primary chamber. We've had this design, at least the two circuits or tandem brake master cylinders, mandated by the federal government since 1967. Prior to that, we used a single circuit, which meant that if you had a hydraulic leak in any part of the system, unfortunately your brakes would not work. So after enough people were injured or killed in car accidents as related to a failure in the brake system, hydraulic braking system, the federal government mandated that manufacturers had to use a tandem or a two-circuit master cylinder to prevent leaks from causing the brake system to be inoperable. So as you can see here in the slide, we have the secondary circuit is going to be separated from the primary circuit. Even though the fluid level might drop down due to a leak, this separator right here will prevent one circuit draining fluid away from the other. So again, by dividing the cylinder into two chambers, it provides a safety factor. If one circuit loses pressure, the other one will remain functional. Let's see here. All right, so this will get very complicated. I am going to go over these different pieces here, but you will have to spend the time really looking at this information, trying to understand how this master cylinder works. You will be asked quite a few diagnostic questions in the ASE certification tests. So before you go take one of those tests, make sure that you have a complete understanding of how the master cylinder operates. That way you will be able to answer all the diagnostic questions, because if you do not understand how the cylinder works, you will not be able to answer those diagnostic questions. All right, so the master cylinder body houses the following components: the compensating port. And the compensating port right here, you can see it's called out on both sides here, is a narrow passage between the fluid reservoir and the brake cylinder, and that is going to equalize the pressure between the reservoir and the cylinder chamber when the brakes are released. So if you can imagine, this is all pushed forward because you're stepping on the brakes, and when you release the brake pedal, these springs will shuttle these valves and pistons back to the right side, and pressure that was built up here in the secondary and the primary ports will then release back into the reservoir. So we need to be able to have fluid return back to the reservoir, and it's accomplished through the compensating port. Also, you can see that if we had a problem with our adjustment of the brake pedal, if we had something hanging it up, or back here if we had the master cylinder push rod, if it was too long, it could actually cause these piston cups to be covering the secondary port, or sorry, the compensating port. And if we block this passage, the pressure will have nowhere to escape, and eventually it will self-apply the brakes, and the car will come to a stop. And the brakes on cars are strong enough where the engine cannot overcome them. Okay, now we have the inlet port. So we have our inlet ports here and here, and it is an unrestricted passage that prevents air from being drawn into the system as the brakes are being released. So these springs are going to cause the master cylinder to return back to its home position rather quickly, and to prevent air from being sucked, being sucked into these part of the cylinder. They have this inlet port that allows fluid to equalize the pressure on both sides of this piston, so we are not drawing air into the system when the brake is released. Okay, and then we have these piston cups. So here is our piston cup here. There's another piston cup over here. Of course, we have another one here. So, and we're also going to have a piston cup over here. So these guys are going to block the flow of fluid or seal the fluid in these different chambers. And then, of course, the return springs are going to keep the components moving. When the brake pedal is not being applied, it's going to return it back to the home position. And some master cylinders will have a stopper bolt that will limit the secondary's piston travel, so it keeps it in this home position right here between the compensating and the inlet port. A lot of master cylinders do not have this. It's just built into the cylinder itself. So when the system is at rest and the brakes are not applied, the piston cups attached to the face of the primary and the secondary pistons are positioned between the compensating port and the inlet port. So just realize that this is super important, that in the home position or at rest position, these piston cups have to rest in between the compensating and the inlet. If we cover one of those up, we are going to experience problems. I know this is very difficult to see what this is doing, but when the brakes are applied, the brake push rod is going to move the primary piston to the left. So please take a look at the animation that I've attached in Canvas. So the push rod is going to first actuate this piston here, which is going to act on this spring. This spring is a lighter spring than the secondary spring. So on the initial movement, this guy right here is going to create pressure in this port first. Once pressure builds up in this port, it will have enough pressure to overcome this spring, and then this guy starts to create brake pressure. Anyways, the piston cups will then cover, you can kind of see it better here. I know this is not a very good picture, but the piston seal or cup will then close off the compensating port and allow pressure to build in the chambers. Okay, so when the brakes are released, so you can see here that if you look at this picture closely, you'll see that this is actually with the brakes fully applied. You can see that the pistons are well ahead of the compensating in the inlet ports. And so what's going to happen is that these springs are then going to return this whole assembly back to the home position. And so what's going to happen is that we need to allow fluid to come in. Basically, when this is returning back to the right side, we need to make sure that fluid has an unrestricted flow back to the reservoir through the inlet and compensating port, because there is a larger pressure here and a larger pressure in here. And once this uncovers the compensating port, the pressure in here will then be vented back into the reservoir. And we're going to use these ports to equalize the pressure in the chamber here and in the chamber here. So once we're back to the home position, fluid pressure will equalize from this side to this side. All right, now take a look at this. This is a little bit better picture. If the primary circuit loses pressure here, the brake pedal will move with little resistance until the primary piston contacts the secondary piston. So what that means is that the primary piston, since there is no fluid pressure being built up in here and in building resistance in the pedal that we all feel when we step on the brake pedal will easily start falling to the floor until it this primary piston contacts the secondary piston, and this area starts to build pressure. So, and this is in the case of a loss of pressure in the primary circuit. If the secondary system loses pressure, pressure will still continue to be created in the primary chamber, and the pedal will still fall close to the ground, but instead of the movement being all in the primary piston spring, this secondary spring will collapse, mechanically bottom out here, and then pressure will be allowed to build in the primary circuit. So in either case, whether we have a leak in the primary side or the secondary side, mechanically we should still be able to build pressure in the system because we have these mechanical stops built into the master cylinder. Okay, and then we have this other one called a portless master cylinder. I'm not sure if this animation will work, but let's try it out.
In Toyota vehicles equipped with ABS or ABS track, a new style portless master cylinder is used. This master cylinder uses a single, non-restrictive passage between the reservoir and the cylinder in one or both hydraulic circuits. Brake fluid is transferred to the circuit through a machined passage in the piston that is controlled by a valve. This valve is spring-loaded to seal the piston passage. However, a stem attached to the valve keeps it from contacting the piston in the at-rest position. When the brakes are applied, the valve closes, sealing the passage and allowing pressure to build in the circuit.
So the question you have to ask yourself is, if this area that is supposed to seal, if there is a leak here, how is that going to be felt in the pedal? What is the customer going to complain about? These are the things that you need to be thinking about as you try to understand how these systems work. It's all about understanding the different types of master cylinders. That way you have an understanding of, you know, how this is going to react when the customer is driving the vehicle. That way, again, this is how we have to be able to diagnose these problems. All right, this guy does not want to move from me. Let's see here. I have to exit. Sorry about that. All right, here we go. All right, so the brake fluid level warning light switch. I understand this is a little bit difficult to understand. I think seeing this here, when you guys come out to the vehicle, you'll see a little float hanging out in the cap. Some vehicles, this is part of the cap assembly, and in most vehicles, this float is part of the reservoir. So if we have a problem with the switch inside here, we're going to have to replace the reservoir because it's all one piece. The switch is normally in the off position when the fluid level is within specifications, and if the fluid level drops, the switch float contains a magnetic switch that will close this reed switch. So essentially what I'm saying is that, and please pay attention to this right here, when the float is in basically the good or full position, the switch is open, and when the float falls to a predetermined level, once it falls below that, we're going to close the switch, which will turn on the red brake warning light on the dash. A quick way to diagnose if you have a problem with this switch, or if you believe that if you're checking for low brake fluid, a quick test is to disconnect. There is an easy switch connection here. You can disconnect it, and if that causes the light to turn off on the dash, even though you have a full master cylinder reservoir, that is a quick way to diagnose if the switch has a problem. And it happens quite often. Even though the brake reservoir is completely full, if the switch has a problem, it will turn the light on, even though the fluid is at the proper level. So the quick test is just disconnect the connection here at the reservoir, and if the light goes off, you found the problem. And the repair is replace the switch here, which means you're probably replacing the reservoir. All right, the red brake warning light circuit. So take a look. There's a couple different ways in which this light will turn on. One is the brake fluid switch, and the other is the parking brake. In older vehicles, when we had oh no, I'm forgetting the name of the valve, but they have this. In older cars, we had a combination valve, and it had the ability to determine if there was a differential in pressure. And now I remember the name of the valve. It's the pressure differential switch. And if you could imagine, there would be just another circuit built in. So we have the brake fluid level switch, parking brake switch, and then we would have this pressure differential switch. And in those vehicles, there were 3 ways in which we could turn this red brake warning light on the dash. But since we have ABS and we've largely gone away from those combination valves, the only 2 ways in which we're going to get a light now, the red brake warning light, is through the fluid level switch or the parking brake. All right, so we have different ways in which we've split up the brake system. Remember, we're using a tandem or a dual circuit master cylinder, and so conventional, or kind of the older way of doing things, or on older trucks and rear-wheel drive vehicles, this is how we used to do it. We called this a front-rear split. So the front wheels were on one system, and then the rear wheels were on a different system or different circuit. And if we had a leak in the front, only the rear brakes would work, and this is kind of scary because you hit the brakes real hard, you could lock up the rears and cause the vehicle to lose control. So now the way we do it is we do this diagonal split where the left front, right rear are connected, and the right front and the left rear are now connected. So this is a diagonal split, and this is how we do everything now. All right, so this is the different type of brake tubing that we're going to be using. Brake tubing is made out of seamless steel. The copper plated steel sheets are typically plated with tin and zinc for corrosion protection. So you will see this question on an ASE test. They will ask you, what is the brake tubing made out of? And your correct response is seamless steel. The tubing connects the brake system network of hydraulic components. Each end has a custom double flared fitting and is fitted with a flare nut. And you can see that we are going to have a 3-degree interference fit in the fittings, so that when you screw these down and tighten them up, the interference fit is what creates the seal here at the tubing. So double flare is what we used to use. It was the most common, and now they're calling this the S-type flare, but this is called a bubble flare, ISO bubble. I'm trying to think if there's any other words that we call this, but this is called an ISO bubble flare most typically, and it requires a different type of flaring tool to create these flares, and you can see how they're different. Okay, so we've moved to this type of flare, and you can see that since the way this is bent, that it actually acts like a spring, and it creates a better seal than the double flare type here. All right, so here's our master cylinder, and we have to bleed this master cylinder before installing it on the car. So you fill this reservoir up with brake fluid. We do have a kit that acts like a one-way check valve. In this picture, the technician is using their fingers to bleed the fluid. Basically, they're going to push this so fluid escapes through the outlets, and before releasing the backside of the master cylinder, cover the ports with your fingers and it will draw fresh fluid from the reservoir to fill up the master cylinder. If you don't cover the ports when you're releasing the master cylinder push rod, it will draw air from the ports and will not bleed out. So I found that just using the kit and is very effective, and plugging these things up until you attach the brake lines is key. And then brake bleeding, remember up, down, open, close. That is the procedure of building pressure. I am a fan of manual bleeding. I think that's the best way to do it. The next one would be pressure bleeding. That's a superior way of doing it. It just takes a long time to set up if you don't have the correct tooling. If you have the correct tools and everything in your service bay, pressure bleeding makes it easy because you can do it by yourself. But manual bleeding, I like that because it's just quick and easy, and it doesn't require any special tools. And remember, for at least for the Toyotas that we have in the classroom, we always go from the farthest wheel to the closest wheel to the master cylinder, and unless directed by a scan tool or by service information. So you need to look that up for every car that you're working on. Okay, I think that pretty much wraps it up for this little spot here. The next thing we'll be talking about is disc brakes, but we definitely need to spend a little bit more time talking about the hydraulics. All right, well, I hope you guys are doing well, and I will continue to work with you guys in the shop. Have a great day.